When we turn our eyes to the sky, we're actually looking into the past. By the time the light of a star reaches our eyes, it has already set out on its journey, sometimes thousands, sometimes billions of years ago. We are merely the final stop of that journey. But what if I told you that we could look back to the infancy of the universe, to the moments when galaxies first came into being, when the very first stars tore through the darkness and lit up the cosmos? This is exactly what the James Webb Space Telescope does. It is humanity's most powerful eye ever built to understand the universe. Its story is not only one of engineering, but also of patience, cooperation, and imagination. Imagine a telescope whose eyes are made of gold, and when it looks, it can see not just the stars, but time itself. Shortly after the birth of the universe, the first lights pierced through the darkness, but those lights are no longer visible. Cosmic expansion has hidden them behind an infrared curtain that our eyes cannot see. James Webb is the key that unlocks that curtain. So how did this telescope achieve the impossible and give us clues ranging from the infancy of the universe to signs of life on other worlds? This is humanity's greatest eye and the only gaze capable of seeing the most distant past. What we will see with it may change not only science, but perhaps even our understanding of who we are. Now, let's look through the golden eyes of James Webb and journey both far away and far back in time. In 1990, when the Hubble Space Telescope was launched, humanity made a giant leap in its view of the sky. We saw galaxies, stellar nurseries, and distant planets. But there was one thing Hubble could not show us: the earliest moments of the universe. The first light of the universe, after traveling for billions of years, had shifted beyond the visible spectrum into the infrared. Hubble could only see this region to a limited extent. Scientists began to dream of a new telescope, more powerful, more sensitive, and specialized in the infrared. In 1996, this dream was first put on paper under the name Next Generation Space Telescope. At first, it was planned to be smaller, cheaper, and simply a successor to Hubble. But over time, scientists' ambitions transformed the project. The goal was no longer just to surpass Hubble, it was to look at the birth of the universe. This would become the most complex spacecraft ever built. A massive infrared eye, gold-coated mirrors, a sunshield the size of a tennis court, and all of it had to work flawlessly 1.5 million kilometers from Earth. But the journey was not easy. The project faced years of delays, billion-dollar budget overruns, and technical problems. In the mid-2000s, it came close to being cancelled altogether. Yet the scientific community did not back down. NASA, ESA, and the Canadian Space Agency understood the value of this mission for humanity. Dozens of countries, hundreds of universities, and thousands of engineers united for the same goal. In 2020, a new launch date was set, but then the global pandemic hit. Like the rest of the world, the JWST team faced forced pauses. Everything was delayed once again. But this time, the final hurdle would be overcome. And on December 25, 2021, the world witnessed the launch of the largest telescope in history. The Ariane 5 rocket quietly carried this golden-eyed giant into space. The month-long journey began, a journey that marked the start of a new era for both the telescope and humanity. Along the way, the telescope unfolded like an origami. Every movement had to be carried out with millimetric precision. A single mistake could have ended a $10 billion project. But everything went perfectly. Now, 1.5 million kilometers away, in complete silence, James Webb was ready for duty. The stage was set for the most breathtaking scientific discoveries in history. The James Webb Space Telescope is the most complex scientific instrument humanity has ever placed in space. What makes it unique is not just its size, but also its flawless engineering. First, its primary mirror, Webb's eye, is 6.5 meters in diameter and made up of 18 hexagonal segments coated in gold. This gold coating is only 100 nanometers thick, designed to reflect light with maximum efficiency. The mirror is built to capture infrared light, which is what visible light from the farthest corners of the universe becomes after traveling for billions of years, shifting into red and beyond. To observe in infrared, the telescope must be kept extremely cold. This is why James Webb has a massive sun shield. The shield is the size of a tennis court and consists of 5 layers. Each layer gradually reduces heat. One side, facing the sun, can be around plus 85 degrees Celsius, while the other side drops to an icy 233 degrees Celsius. So why isn't James Webb in Earth's orbit? Because it needed to be as far as possible from the heat of Earth and the sun. That's why it was placed at the second Lagrange Point, or L2, 1.5 million kilometers away. L2 allows the Sun, Earth, and telescope to remain in the same relative position so that the sun shield can block all heat sources. It also provides a stable view for long-term observations. James Webb carries 4 main scientific instruments: NIRCam, near-infrared camera; NIRSpec, near-infrared spectrograph; MIRI, mid-infrared instrument; and FGS-NIRIS, fine guidance sensor, near-infrared imager, and slitless spectrograph. These instruments do more than just take pictures. They can detect whether the atmosphere of another world contains water, methane, or other signs of life. Together, they make James Webb not just a telescope, but a time machine. After months of calibration, testing, and fine-tuning, humanity saw James Webb's first images on July 12, 2022. And what we saw was breathtaking. First came the SMACS 073 deep field image. Every point of light in that picture was a galaxy containing billions of stars. The light from those galaxies had traveled for over 13 billion years to reach us. Looking at that image meant looking into the childhood of the universe. Next, the hot gas giant WASP 96b was observed. By analyzing the starlight passing through the planet's atmosphere during transit, scientists detected water vapor, one of the first signs of the telescope's power in the search for life. When the Cartwheel galaxy was imaged, astronomers saw the details of galaxy collisions. Webb's infrared eyes revealed newborn star clusters hidden behind clouds of dust. Images of the Carina Nebula showed star formation processes as if peering into a cosmic maternity ward. Stephan's quintet displayed galaxies performing a cosmic dance. James Webb is not just taking images, it is seeking answers to humanity's greatest questions. When did the first stars form? How did black holes grow so massive so quickly? Are we alone in the universe? Roughly 200 million years after the Big Bang, the Dark Ages ended and the first stars were born. Webb is the first telescope powerful enough to capture the light from this era. Some black holes had already reached enormous masses when the universe was still young. Webb will help us understand how they formed. It is also studying the atmospheres of exoplanets in habitable zones, detecting gases linked to life, such as water vapor, methane, and carbon dioxide. It is revealing the evolution of galaxies, the role of cosmic dust, and the regions where stars are born. James Webb's mission is officially set to last at least 10 years. In the coming years, it will map the first star clusters, analyze the atmospheres of hundreds of exoplanets, and study the formation of black holes in early galaxies. After Webb, new telescopes such as LUVOIR, HABEX, and the Nancy Grace Roman Space Telescope will follow. Looking at the sky is one of humanity's oldest habits. James Webb reminds us not only of how vast space is, but also of how curious, creative, and determined we are. Every image it sends is light from billions of years ago, being reborn today. Perhaps one day, James Webb, or its successors, will find signs of life on another world. That day will mark the beginning of a new era of discovery for humanity, because we will never stop looking at the sky.